Hi, in this video, I will be showing you problem number 7 of chapter 2, section 2. For the function g, whose graph is given, state the value of each quantity if it exists. If an answer does not exist, enter does not exist and say why. The graph is shown here. The questions are A. Limit is t approaching 0 minus g of t. B. Limit is t approaching 0 plus g of t. C. Limit is t approaching 0 g of t. D. Limit is t approaching 2 minus g of t. E. Limit is t approaching 2 plus g of t. F. Limit is t approaching 2 of g of t. G at 2. H. Limit is t approaching 4 of g of t. We will mark the t-axis and the y-axis, and wherever the two axes meet, they meet at the origin, 0. Now, we have to consider the first part, limit is t approaching 0 minus g of t. T approaching 0 minus means t approaches 0 from the left side of 0. So g of t is the graph that is drawn in pink. So we have to find out the y value corresponding to the value t approaching 0 from the left side of 0. So now we have to look at the graph as t approaches 0 from the left side of 0. So the graph is actually having a solid dot at -1. So this value -1. So limit is t approaching 0 minus g of t is -1. So the way to interpret t approaching 0 minus is as t is approaching 0 from the left side of 0 or through values smaller than 0. Now, second part, limit is t approaching 0 plus g of t. The way to interpret this is t is approaching 0 from the right side of 0. So we have to look at the graph on the right side of 0, in the neighborhood of 0, but on the right side of 0. So we see this piece of the graph, and this is actually having a hole at -2. So anytime you write the value here, it should correspond to the y value. So it is equal to -2 when t approaches 0 from the right side of 0. The third part, it is limit is t approaching 0 g of t. The way to interpret t approaching 0 is that we have to consider the left limit at 0 and the right limit at 0. Then we have to decide whether the two values are equal or not. From part A and part B, we said that left limit at 0 is -1, the right limit at 0 is -2. The two values are not equal, so you have to say it does not exist. The reason that you would give the left limit is not equal to the right limit, so that the limit does not exist at 0. Now we have to consider part D, which is t approaching 2 minus g of t. So we have to see the graph and what happens in the neighborhood of 2, but on the left side of 2. So we have to approach t to 2 from the left side of 2. So we see this piece of the graph. So the graph is actually approaching 2. The y value is approaching 2. So this is equal to 2. Now limit is t approaching 2 plus g of t, which means we have to approach 2 from the right side of 2. So if it will consider the graph of g in the neighborhood of 2, but on the right side of 2, so we see this piece of the graph, which is approaching 0. We have to consider the y value. So we see a point, actually we see 2, 0, there is a hole. So the value is equal to 0 in this case. Now limit is t approaching 2 g of t, which means we have to approach 2 from either side of 2. From part D and part E, we notice that the limit as t approaching 2 from the left is equal to 2. From the right, from part E, the limit as t approaching 2 from the right is equal to 0. that the two values are not equal, so the limit as t approaching to g of t does not exist. The reason that you would give left limit is not equal to the right limit. The last part is limit as t approaching 4g of t. So in this case, you have to consider either side of 4 because it doesn't say which side it is from. So it is asking just limit as t approaching 4. So you have to consider what happens when the limit, when t approaches 4 from the left side of 4, which is equal to 3 from here, from the graph. On the right side of 4, also it is equal to 3. So this is equal to 3. So the reason that you would give left limit is equal to the right limit, both are equal to 3. Hope this video helps.